In this lesson, we're going to continue with the topic of integration and study differential equations. So, we know that we've previously learned that integration is the reverse of differentiation. So, as a result, if we integrate the derivative of a function, then surely we will obtain the original function. So here we've got the integral of dy by dx, the derivative, with respect to x, and when we integrate that, we get y, which was our original function before differentiation occurred. Likewise, if we take the integral of f dashed of x, the derivative, and we differentiate that with respect to x, then we obtain f of x, which again would have been the original function before differentiation occurred. Now, what the above obtains is called a general solution for the original function, because we'll have the constant of integration included as well. However, if we've got additional information about the function, then we can find the value of that constant of integration, and that allows us to obtain a particular solution, which is much more useful. So let's have a look at an example. We've got example 1, the graph of y equals the f of x passes through the point 3, negative 4. If dy by dx is equal to x squared minus 5, express y in terms of x. Okay, so we need to think here we've been given the derivative. Okay, so, and we're asked to find y. So we need to integrate that. So if we integrate the derivative, we've got the integral of dy by dx with respect to x is equal to the integral of x squared minus 5 with respect to x. Now, obviously, if we integrate the left-hand side, then we obtain y. And on the right-hand side, if we integrate x squared, we get x cubed over 3. And integrating negative 5, we get negative 5x. And we've got our constant of integration. Now, what we have obtained here is called the general solution, but we would like to get a particular solution. And we're able to do that. We've got other information in the question. So we've been given the point 3, negative 4. We're told that the graph of y equals f of x passes through that point. So what we can do here is we can observe that we have a y, which is negative 4, and we've got x's here, which are 3. So we can substitute our point in. So we'll have negative 4 equals 3 cubed over 3 minus 5 times 3 plus c. That gives us negative 4 equals 9 minus 15 plus c. Negative 4 is equal to negative 6 plus c, so c is 2. We can now go back to our general solution here. We can say to ourselves, we'll get y equals x cubed over 3 minus 5x plus c, but I now know what c is. It's 2. So expressing y in terms of x, I've got y equals x cubed over 3 minus 5x plus 2. So just now would be a good time before example 2 to copy this example down in your notes jotter and then come back for the next one. Okay, welcome back folks. And example 2, we're told that the function is defined on a suitable domain such that f dashed of x, that's the derivative, is equal to x squared plus 1 over x squared plus 2/3. Given that f of 1 is equal to 4, find f of x in terms of x. So again, we've been given the derivative here, f dashed of x, and we've also been given information about the original function. So that's key here. Generally, if you're given the derivative and then other information about the original function, it will mean that you're dealing with a differential equation, and that's how you would recognise one of these questions in the exam. So we've been given f dashed of x, and we know that if we integrate both sides of this equation, we'll have the integral of the derivative f dashed of x with respect to x is equal to the integral of x squared plus x to the minus 2 plus 2/3 with respect to x. Now, integrating the left-hand side leaves us with our original function, f of x. And on the right-hand side, we can integrate this. So we've got x cubed over 3. Integrating x to the negative 2 gives us x to the power negative 1 all over negative 1. And integrating 2/3 gives us 2/3 x. And we have our constant of integration as well. Now this term here, x to the negative 1 all over negative 1, I know that I can make that look better here. I can express it with positive indices. So that would be the negative of 1 over x. So you can see my general solution here, x cubed over 3 minus 1 over x plus 2/3 x plus c. Now, I would like to gain a particular solution, and this is the information I've been given so far. I've got my general solution here, but I also know that f of 1 is equal to 4. So whenever x is 1, f of x is equal to 4. So you can see where I'm going to substitute here. So 4 is equal to 1 cubed over 3 minus 1 over 1 plus 2/3 of 1 plus c. Simplifying gives me 4 equals 1/3 minus 1 plus 2/3 plus c. And hopefully you can see that that gives me 0 on my right hand side alongside my c. So c must be equal to 4. And I can now go back to my general solution for f of x. And that was all fine, but I had this constant of integration. I didn't know what it was, but I now do. So it's f of x equals x cubed over 3 minus 1 over x plus 2/3 x plus 4. And that is my final answer. So just now would be a good time to pause the video before the screen goes blank and make sure you've copied this down in your notes before trying the exercise on differential equations.